Hello, and welcome to this panel discussion where we're going to be talking about quality engineering and evolution of software quality as a team responsibility. And I'm gonna be a moderator today, and I'm Nikolai Tolkashov, and we have on a panel two participants. And let's start with Rick. So Rick Marsalis is a principal quality consultant at Sogeti, and I had the pleasure of meeting Rick in person this year at TestFest conference in Wrocław. Quite a few discussions were about ISTQB, and in my eyes, he's an expert in that field, and at least from the people I know. If I would had any questions about ISTQB, I would ask Rick before using Google. Yeah, Rick, so anything else you can add about yourself?
Well, apart from ISTQB, I'm also very much involved in TMAP, which the two align very well. And I'm passionate about quality and testing, so that's why I'm very happy that I was invited to join this panel, and I'm looking forward to the discussion that we will have right now.
Great, thank you. And another participant in this panel is Christopher Miller, head of IT and development at School of Code. I don't know Christopher personally yet, but I know he started using computers before I was born. So, Christopher, could you please tell more about yourself?
Yeah, so my first foray into computers was in 1983. My dad brought home a box of electronic bits, a soldering iron, and a book. Now, I thought the fun was going to be soldering this thing together, and that was fun on its own. I mean, I don't know how much help a 3-year-old was on soldering stuff together. It was like, pass me the green bit, no, the other green bit. But from there, we went and plugged it into the telly, and my dad showed me this idea of things happening when you start typing stuff. That was my introduction to computers 40-something years ago. And I've been working in the field since 2000 on and off.
That's very nice. So maybe let's start this discussion with the basics. So, Rick, what is quality engineering?
Well, we define quality engineering in the following way. So, quality engineering is about team members and their stakeholders taking joint responsibility to continuously deliver IT systems with the right quality at the right moment to the business people and their customers. And quality engineering is a principle of software engineering, which is concerned with applying quality measures to assure the quality of IT systems. So it's quite a lengthy definition. And one of the core things in the definition is the right quality at the right moment, because all too often people think they should deliver the highest possible quality, but often the highest possible quality will be too late to deliver business value. So it's always trying to find the right quality at the right moment.
It's about the balancing, right? Okay,
Yeah.
and maybe let's move into the team responsibility question. And I have a bit of controversial one. So, Chris, if I would ask you the question, like if we have QAs and or test engineers, why does software quality should be a team responsibility? Don't we have dedicated people who are really good at that?
So, yeah, absolutely. We do have people that are very talented and work specifically in that area. But for me, it's a team responsibility because the whole product is a team responsibility. If I, as a software engineer, don't write good quality code, for example, then I'm actually making the job of the QA engineer more difficult. I'm making the job of the product owner more difficult. It's also actually making my own job more difficult. Because if I look at my own code and I don't understand what I just wrote, then what use is that to anybody? So for me, it's a team responsibility because it just makes everybody else's job easier. And hey, if you don't know what quality means in a particular scenario, talk to the rest of the team. Somebody will in that scenario.
Rick, what about you?
Well, one of the things I think is very important is the idea of built-in quality. So we are currently at a testing conference, but I have come to the conclusion myself that it's about more than testing. And that's why I like to talk about quality engineering and testing, where actually testing should be part of quality engineering. And the starting point is to build quality in, and then testing would be demonstrating that you succeeded in building the quality in. Whereas a long time ago, testing was just find the problems and then get them fixed. But that's led to a situation where people just created something and then trusted that somebody else would fix it. So yeah, it's an I was going to say it's a new way of thinking, but actually it's quite an old way of thinking, because probably a lot of people still know the Bohm curve by Barry Bohm, or he was an American, so he called himself Barry Beam. But and he was the first one to describe that if you find a problem and fix it early, it's cheaper than if you fix the same problem late. And then later people added it's even cheaper if you don't have a problem, so you don't have to fix it.
Yeah, that reminds me of this famous chart where as later you find the problem, the more like expensive it is to fix, right? So requirements is the easiest one and most like cheapest one, but later it's more and more expensive until it reach production where it could be, well, a very big problem.
Yeah.
So if we know that this mentality, that this is like a better way how to think about quality and it have to be built in. So there's an opposite like not idea, but opposite way how the people are thinking about that. So how to break that, how to make sure that everyone is on the same page and everyone wants and are interested in creating this common, like build quality built-in approach.
So I think for me, that would be focused around honest conversations with the team members. Some people may be looking at the particular software, the particular project that they're working on and thinking we don't have time to worry about the quality at this point, but we need to consider certain aspects of it. If that conversation is open and honest with the team, it may be that the time needs to shift slightly to get a better end result. But as Rick said, it can be different levels of quality at different points. If all we're doing is a proof of concept that something could work in code, then do we need to consider having every possible error caught in that? Do we need to consider having tests for every possible route through? Probably not. But if we're talking about an end user app that's going to be used by people, then we probably do need to be considering more than we would for a proof of concept. The other thing is that people actually natively want to produce the best quality, but they may not know what that looks like at the time. So the definition of quality, although we have a definition of what it means overall, that definition will change per project and per application. And how that's implemented will be different per project, per application, even per team, because it will just depend on the makeup of the team.
Yeah. Yeah, and also the quality level that you can deliver also heavily depends on the available time. What I see when quality is not enough, often that is because teams try to achieve more stuff in, for example, a sprint. So if you have a sprint of 2 weeks, they try to achieve more stuff than you can physically create in 2 weeks. And then they say, yeah, but our product owner wants us to do so. And I think, well, no, but you should take responsibility together. And together means also including the product owner. And if he wants you to make more than you can do, then discuss together, hey, this is what we can do. And we can't do more. And if you say you need more, well, probably we need more teams. And that's often a challenge. And I think the move to Scrum and DevOps already makes it much better, because before that, so if we have V-model based projects, then stakeholders are even more inclined to just push all kinds of stuff towards IT and expect them to achieve miracles.
Yeah, absolutely. And that's part of the key discussion, isn't it? That people are talking honestly about the workload that's involved. They're talking honestly about the requirements that are involved. And simple things like, does it matter that feature A is in sprint 1 or sprint 2? If we put it in sprint 2, we've actually got more time we can dedicate to feature A. And that kind of discussion can also help.
Yeah. Yeah, and in that kind of discussion, I also like to look at risk. So how much risk is associated with this? And then based on the risk, you know how much effort you must put into achieving the right level of quality. Yeah? With more risk, you also want to know, have more certainty about the quality. But sometimes also people will say, there's no risk here. So you don't need to test it. And then the first thing I always say, okay, so we won't build it. Because if there's no risk, if it goes wrong, nobody has a problem. So nobody needs it. So don't waste time on building it. So just skip it. And often then you see a product owner realize that, it's a nice to have, but actually we don't need it. So let's not waste time on it. And that keeps your systems lean and mean.
Yep.
And helps the quality.
Yeah, that's for sure. But some of the situations are that it's not a limiting factor of time or the like how much features we can fit in. But sometimes engineers don't want to spend more time, maybe built-in quality in the products, and it's because, well, we have test engineers for that. Why should I spend my time? I can just push it, and then test engineers will do all the rest. So I think there is this kind of mentality problem as well, right?
Well, yeah, but it's interesting that you bring this up because what you didn't mention in the introduction is that I've been in IT quite a long time, and I was educated as a programmer, actually COBOL programmer, in 1980. So that's 42 years ago. And one of the things I learned during the basic course is no program is ready without a test set with it. So I knew from day one that I needed to do testing as a developer. And now today I come across developers who don't want to do testing. And then I ask myself, where has it gone wrong? Because obviously the best one to build in quality is the one who builds something. And you can't rely on other people to build it in. Now, on the contrary, of course, quality engineering is about taking joint responsibility. So I don't mind if a developer asks me, come and sit with me and let's build quality in together. Or I have a problem and can you help me solve it? And what I also see is that often other people in the team, for example, people with a testing background, then say, oh no, but I don't know exactly about this, so sorry, I can't help you. But just be interested in each other's stuff. If I may give a little example, which happened, well, some 10 years ago. So I was in quality and testing, and somebody else had written some code. And the code was actually in C, so in the traditional C language. And I had never seen C language before, so I didn't know anything about it. But they had an issue with the software, and it said, "Can you help?" Now I could have said, "No, I don't know the C language, so I can't help you." But on the other hand, I said, "Yes, let's have a look. So tell me what it does." And they just told me, and well, I know something about programming, and then quite quickly the two of us together worked out that in this little piece of code, that was where it went wrong. And still we didn't know what went wrong. And then the other person, the developer, looked again and then said, oh my gosh, I have here a variable which is declared as text and it should be numeric, something like that. And so basically, even though I didn't know the language, I still was able to help. And that's how you take joint responsibility for quality.
Yeah, that example is very similar to a concept that's used a lot when we're teaching our students on the bootcamp. We call it rubber duck debugging. The most important member of your team is the rubber duck that you talk to when you don't know what's gone wrong in your code. And it's the act of articulating the code to somebody else or even to an inanimate object that makes it easier to spot that problem in the first place. Sometimes I've jumped onto calls with seniors in a team and gone, right, the problem is this and this is happening. I've done this and this. Yeah, there it is. So they haven't actually told me I've found the problem, but just by articulating it to somebody else is where the problem's identified. And that thing of QA engineers helping, it's right that QA engineers will help, but then if the code that they inherit as a testing engineer or a QA engineer isn't in a place that makes it easier to test and easier to work with, then all you're doing is adding your workload to somebody else. So for example, if I wrote a function that has 30 different routes through, well, then you're talking 35, 40 tests. Whereas if I write a function that has 2 routes through, well, then you're talking 2 or 3 tests. Have I changed what I've written overall? No, I've just put it in slight issues, in slight smaller functionality. And by doing that, it makes the job of everybody else easier just by having things laid out in a way that's simple to understand.
And there, what you apply is one of the important principles from the Agile Manifesto, which is simplicity. So try to make things simple because that adds to the quality, because the more simple it is, the less can go wrong.
Yeah. And I think that would be like beneficial to everyone, right? The more readability, it's not only when you like share the code to someone else, when you come back to that code to refactor or fix something or maintain it, it would be much easier to work with that kind of like level of quality, right? Okay. So any hints how we can help non-QA team members so they could have the right skills to help with the quality? Maybe some kind of trainings, books, workshops. What help you or you seen in practice helped others to become better at delivering, creating better quality?
Well, if you allow me, I would like to start with, you asked for, are there some books? Well, I have the cover in my background here, the book Quality for DevOps Teams. And it's called, it is a book in the TMAP body of knowledge, and TMAP used to be known for testing, but we realized that everybody should be involved in quality. So it is about quality now, and therefore we call it Quality for DevOps Teams, because everybody in the team should be aware of what is quality, why do we want quality, and what level of quality would be the right quality. And of course, we have some training courses with that. And then, but in general, that's not the only thing you need. So you need to know about quality engineering and more. And now one of the problems with DevOps is that some managers seem to think that in a DevOps team, you have developers, that is programmers, and you have operations people, so that do maintenance of the system, etc. And that's it, because it's called DevOps. But they don't realize that it could be that way if these developers and these operation people have all the capabilities that you need in a cross-functional team. But in real life, you don't have so many people that have all these capabilities. So you need multiple people that together have all the capabilities. And then, for example, our book and that kind of training courses, they make sure that the people have enough knowledge to understand each other. Not necessarily should they all be at the same level of the capabilities you need for quality, but at least you need to have the same understanding. And then I know Chris does a lot on training, so you probably have something to add.
So, from a training point of view, we actually provide a 16-week bootcamp for people in the UK. That there are no technical requirements up front for anybody to join us. A lot of from our side is on the software side of things and thinking about code and how you write that code in the first place, how you'd implement tests for that code. One of the resources, despite the controversy around certain actions in his work life, would be the Robert C. Martin series, the Clean Code 4, and there's about 6 books in that series. Clean Code Architecture is one that I really like, and the examples are written in a language that looks very similar to Java, but it's not. It's actually a language that is created for the purpose of the book, and it's just to give clear examples in a way that makes sense. The best resource, however, I know I've said this on every question so far, but is your own team, because that quality will look different in every single scenario. And your team will have a way of working that meets the requirements that they have. So every time I go into a new team, I may have 22 years of experience, but my experience of writing code their way is probably 0. So I would rather go and sit with the team and go, right, here's how I'd answer this question. How would you answer the same question? How would you meet the same requirement? And by having those conversations early, I get into the process of writing using the styles that they have for the code and using the set of tools that they have. Another one that really, really helps is having different tools within the languages. So in the PHP world, for example, you would have PHP Stan that analyze the code and tell you if there are issues in the code from a static analysis point of view. So effectively what it does is it looks at your code, breaks it down, and it tells you whether the code meets a set of rules that you've defined. It works a bit like a linter in that sense, but it's more about the functionality than the look and feel of the code. So, for example, nested if statements. Some companies don't like nesting more than one if. So if you've got 3 ifs in a row, it gets complicated to understand that path through. And the linter can be set up to tell you, the analyzer can be set up to tell you that you've got this in here, and in most cases can suggest alternate ways of writing it. Other things to look at, honestly, just reading code, and reading code that feels good to read. I do a talk called Clean, Concise, Collaborative Code, and that talk I finish off with 2 questions. The first question being, can a non-developer understand what is happening in your code, even if they can't understand how? If a non-developer can understand what's happening, then it probably means that your code is clean enough for anybody to pick up on. And the second question is, if you were hit by a bus tomorrow, could somebody else pick up on your code and carry on? Well, if the answer to that is no, then perhaps you need to go back and look at it.
Yeah. One thing I would like to extend somewhat is that, Chris, you refer mostly to the code quality, and then I have learned over the years that both code quality and the overall business process quality are very relevant. And often, for example, product owners don't care much about code quality. So the team should care about it because the product owner doesn't require it. But the other way around, the kind of quality a product owner may care for is not always the kind of quality that appeals to every team member. And that's the reason why, for example, somebody with a quality and testing background can add to a team of developers, because sometimes developers are simply, and I don't mean to offend anyone, but are simply so technically inclined that they don't understand the functional worries of a product owner. And during my career, I've often done the translation between, because I know about technical stuff, because I have been a developer myself, and I know about the organizational stuff, and then you can translate. And that's one of the things in quality engineering, when you talk about joint responsibility, it's also joint understanding. and yeah, it often starts with asking the right questions.
Absolutely. The questions are what set the path from the very start. It's
Yeah.
And I've worked with people who are QA engineers that have added to the code simply by saying, well, I don't know how to test this bit because of this, or actually, have we considered this scenario? There's a famous tweet by a QA engineer that says a QA engineer walked into a bar, ordered -1 beers, ordered 1,000 beers, ordered a lizard. First real customer walks into a bar and the bar bursts into flames. The whole idea there that the QA engineer had gone through 20 different things and then had missed something else, whereas the software engineer might have picked up on that but then missed some of the tests. The two side by side end up with a much better end product.
Yeah. Yeah, and then another thing is that you also should think about what are the things, for example, what are the tests that really matter?
Yep.
I still vividly remember a conference talk, I think it was like 20 years ago or something, where somebody demonstrated that if you have Microsoft Word and you have more than 32,000 pages, something goes wrong. And then I wonder, what book has more than 30,000 pages? So, yeah. So that kind of, it's nice that you can demonstrate that something goes wrong, but nobody cares because it's not a risk.
Yeah.
Yeah.
It's an edge case, right?
Yeah. And
Yeah, it is.
it's covering the right edge cases, so that there will always be edge cases that you're not necessarily going to cover with tests. But if you've got the edge cases that are most likely, then you will have something that covers that in your suite, whether that's testing, whether that's part of the manual testing process. But sometimes you might miss one. That's okay. Add it to the test suite for the next time.
Yeah. On the other hand, what I think is important to teach people in a team is basic understanding of at least some fundamental test design techniques. Because let's take boundary value analysis. I all too often see people, especially if they are not with a technical background, that they have to test a boundary and then they just test the boundary value. So let's say if you're 33 or older, you get a discount. Well, they test 33, it gets a discount, and they're happy. But a simple thing as also test 32 and see if they doesn't get a discount, that's a very simple understanding. And after you explain it once to people, it already starts sinking in that quality is a little more than just trying if something works. Because you also try if it doesn't work in the other situation.
And conversely on that, you wouldn't necessarily test, if I am 1, do I get a discount? If I am 2, do I get a discount? You test the extremes of each scenario. And I have in occasions had one where I've generated a random number when it's something based on that I guarantee is above. So you've got a test on the boundary and one that's a random number. By doing that, I've then shown that it will handle other numbers as well. The other sort of things to watch out for are the quirks of the language. Something so stupid as 0.1 plus 0.2. If you expect that to be exactly 0.3, in many languages it isn't, because of floating point errors. And simple things like that can catch you out. So testing those sort of quirks that you know of. And hey, if you come across a quirk that you don't know of, again, add it to the test suite for the next time and handle that in the code.
Yeah. Yeah. And for that reason, I still think it's nice that I was educated in the time that binary and calculation was still considered important. Because I know that numbers like 255 are important numbers because that's the maximum value of 1 byte. And then, so sometimes people are very surprised that 256 goes wrong. Why does...
And the other one that people forget about is 32767, which is the upper first 16-bit. So once you've got to that point, you're then dealing with slightly newer machines, and I can't remember the full number, but there's a ridiculously long one for 64-bit. And people forget that these things still apply because the numbers are so huge these days that you forget about it. But somebody like Google could quite easily get 32,600 whatever it is of things in one day, and quite easily run out of space to store it.
Yeah.
I can't remember the last time I had 32,000 visitors on my website.
So maybe you worked on a projects or in teams where quality was solely QA responsibility, and the teams where quality was distributed, like it's a team responsibility, right? So maybe you have worked in both cases, and you can compare what is the difference in culture, deliverables, overall quality, and project or product success.
Well, I mainly remember the separated responsibility from the era of sequential IT delivery, so where you follow a V model. And then it was quite normal that you had a department with developers and a separate department that did system testing. And then you got what we refer to with the famous word bug ping pong. So you throw a piece of code to the testing team, and then the testing team says it doesn't work, and they throw it back, and the developer says works on my machine, and the testers say we won't ship your machine, and then you get all kinds and instead of solving it together, they just blame each other for distracting them from real important work. And therefore, I'm happy that nowadays we focus on cross-functional teams with all people working together.
For me, I've worked on teams where it's been the other extreme. So there's been neither party have been responsible for quality, and neither party have taken an interest in quality. And the QA in that particular team was based around, here's a set of scripts and we're going to through and we're going to do these things, which is absolutely great if every user gets that book on how to use it. The problem with users is they try to use things like we don't intend it to be used. And I've actually found with my experience that the best thing I can do to get a real quality assurance is go, yeah, okay, we can write our tests, we can make sure that we've considered the edge cases, we can do all of this, but give it to a user and tell them to break it. Because they will. They'll find a way of breaking it. But that's actually a good thing, because the user can then feed back to you at an early stage, actually, this isn't quite working as I'd expect it to. Or why is that button over here and not over here? Those sort of conversations can also improve quality, because quality is also about the user's experience of the product that you're creating. That age-old story of creating a product to solve an issue, it's probably not true, but it's an old story of trying to write in space. And NASA were asked the question, well, we need a solution for writing in space, so they've spent $3 billion to create a pen that could write in zero gravity. The Russian cosmonauts were asked the same question and took out a pencil.
Yeah. Which always writes.
Yep.
Yeah. And you say it's probably not true, but the pen does exist. I don't know if it costs 3 billion, but the pen does exist. And in some way they put pressure on the ink so that the ink comes out no matter in what situation. But indeed, sometimes it's better to first think about several possibilities instead of just going for the first obvious one. Yeah. And the other thing that I think all too often people forget is all the different angles, I might call them, of quality, known as the quality characteristics. Because we have a list, the most recent ISO standard on that is the ISO 25010, which has 8 characteristics for product quality and 5 for quality in use. And all too often, most people in the team and outside of the team only think about functionality. So what is it supposed to do? But all the other things are also very important. And what I think is interesting is that with the new possibilities that IT brings, you also need new quality characteristics. One of the things I've been involved in is testing of artificial intelligence. And if you want to test artificial intelligence, the original 8 product characteristics are not enough. For example, with artificial intelligence, suppose you are testing a chatbot, you also need to test the personality of the chatbot. Because if you are building a chatbot for high school kids, the chatbot can use very popular language like "Hey dude" and that kind of stuff. I hope this is high school language because I've been out of high school quite some long time. But if you are building your software for senior citizens, then the personality of your chatbot must be different. And so quality is important, has very many aspects, and even using the standard lists may not be enough. And people need to think, are there other aspects of quality that we need to do? And a thing that I've been involved in lately is sustainability. And my first thought was, why would we need sustainability as a separate quality characteristic? Because actually, you can cover sustainability with some existing characteristics already. But now I've learned that sustainability is such a hot topic that people want to explicitly pay attention to it. And then why not just do what most people feel is needed instead of trying to explain to them that there is somewhere in the standard or already something that is about sustainability. And so, and that's the nice thing, that the perception of quality keeps changing and improving, and thus we as teams also need to improve with that.
Yeah, totally agree with that. Maybe one thing that some sort of question I do have, building on Steve's keynote from today. So he said that we should delete the column for QA and just always it's a development and always working as a team rather than just like separate departments of some sort. And what I hear from Rick, what he said, and he was learning when development in early days, there was like test cases was part of the development process. So maybe by introducing QA as a role, as engineers in the teams, we actually added some kind of like toxic relationship where everyone else is pushing away all the responsibility of quality to that dedicated persons, right? To the test engineers. But maybe we can write better. Maybe I don't need to write such a great requirements because test engineers will catch all the edge cases, all the like missing requirements and misalignments, and developers as well. There's someone else who can do testing better and faster, maybe more efficient than I. Maybe I can push it later in the later stages, and this kind of. It makes sense, right? It does ring a bell. It seems that everyone's like moving away from quality.
How I read the thing that Steve mentioned, so remove the QA column, is because I would say you have a design task, a development task, and a testing task for the same part of your system. And then any person in a cross-functional team is allowed to pick up any task. So if I see a very basic development task, for example, somewhere in a piece of code, a greater than symbol must be changed to a less than symbol, I can do that. So I pick up the development task and then somebody else tests it, because we take joint responsibility. So don't test your own stuff. So I do a code change, somebody else tests it. And then there is a massive, very complex, whatever language coding task. Well, probably I can do it unless it's COBOL, but you don't see that anymore. But then it also needs to be tested, and probably that testing is also quite complex. And hey, I have quite some experience with testing, so I'll pick up that testing task. So we have separate tasks for delivering the end result. And depending on the capabilities and the availability of the people in the team, you pick up some of these tasks. But by no means one person can say, I only pick up development tasks or I only pick up testing tasks. You take responsibility together, and and if you work in sprints, what you often see is that at the start of the sprints, there's quite a lot of design and analysis tasks and coding starts. And at the end of a sprint, often there are some testing tasks remaining. For example, the whole business process testing or end-to-end testing or whatever. And then, so you see a shift of the emphasis of what team members are working on. And all of them make that shift. So because the teams that don't apply this kind of thing, they still add new code on the last minute of a sprint. And that can never be tested properly anymore. So that's also the awareness of quality, that, who works on what and how do you divide the work. But I totally agree with Steve that you should not have a QA column.
Okay, so I think we're running out of time and we only have 4 minutes left. So maybe let's, time flies by very fast when you have a panel discussion. So I can maybe read one of the questions, and we might get a few of them. So how to increase the team responsibility in terms of quality?
One little anecdote on this: as soon as you introduce DevOps in the proper way, and I'm painting a black and white picture, so don't forgive me for that. But in the old days, developers didn't care much about quality, because if the program failed in the middle of the night, the operations guy was called out of bed and had to fix it. If you implement DevOps properly, the whole team gets called out of bed and has to solve it. So the developer will think twice for not delivering reasonable quality, because he himself will have to get out of bed to solve it. So that's one of the ways to increase the responsibility for quality. But I guess Chris has more.
I think for me, one of the key points on that would be, again, it goes back to that whole team discussion. And it really is the key to unlocking all of quality in a team, is just talk about it. And like you said, there are times where, yes, things will go wrong, and yes, you will get that call in the middle of the night to go and fix something. But hey, if you've already put resilience in place and the server hasn't gone down because the code crashed, well, then you've already done one of it. If the server goes down because AWS's availability zone is not available, but you've already put in place something that says, hey, I'm not available in this zone, go and put me over here, please. Well, then you're already answering some of these quality and sustainability questions. The other sort of areas would be looking at rather than looking at the hierarchy of junior, mid, senior, and hey, quality is the senior's responsibility, having that conversation with even the first lines that a junior writes in the team, and looking at how does their code fit into the rest of the code base. A lot of the time early on in a code base, we'll look at code in isolation. So we'll go, hey, I'm dealing with this bit that deals with the users, so I don't need to worry about what it's doing over there with addresses, but you might actually change something. With that whole thing of QA at the end, it's about, that's almost for me a user acceptance test. So is the user comfortable with it?
Yeah.
It's not necessarily about guaranteeing the quality of what you've created. It's guaranteeing that the user is comfortable with what you've created for me.
Yeah, and this makes like a lot of sense, and I think that would help everyone, right? If we could everyone would do that, and then the end user would be more happier, and teams would be more like resilient and more happy working in that environment. And I think we're running out of time.
Oh, okay.
It's like 1 minute left, and I need to. We need to say goodbye. Okay.
One little thing that I wanted to add is that people should think not only of the quality of the product, but also of the process and the people. Because if people and the process get better, it's also easier to create high quality products.
Yeah, that's for sure. Yeah. Okay, so I guess we didn't manage to answer all the questions, and we might think of how we can solve it and maybe answer it offline. But thank you, Chris. Thank you, Rick, for thank you, Chris, for talking about this topic. I think it's still important. It was an important topic 40 years ago, and it's still an important topic now, and it's always evolving, right? So maybe next year we're going to have something different which evolved from this topic. Yeah, who knows? And thank you for all the listeners and participants for like hearing and staying with us. And if you have any questions, you can find us on LinkedIn and maybe just try to get an answer from us directly. So thank you, and have a great rest of have a great keynote, because it's up next. Thank you.
Yeah.
Bye.
Thank you, everybody. Bye-bye.
Bye.